Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I kind of like to request our members to subscribe. Also ring that notification bell to be getting updates on our various uploads in mathematics and sciences. Now in our discussion today, I'm going to look at the principle of superposition of charges. And this is going to follow our previous two discussions we have done on the concept of an electric charge and a Coulomb's law. Now, in our previous discussion, I had mentioned that basically Coulomb's law is going to apply to n pair of point charges, whereby we had given an example of a general case for the two charges being given in terms of Q1 and Q2. And of course, we had said that the distance of separation between the two charges can be given in terms of R. And we said that considering these two charges for the first one and the second one, we can establish the force of attraction or repulsion between the two specific charges using what we refer to as Coulomb's law. Now, Coulomb's law gave us a relationship between, or rather a relationship that is going to be applied for the these specific forces which we have mentioned, whereby we said that this particular force which we had given in terms of F is directly proportional to the product of the two the charges of the two specific particles and inversely proportional to the square of the distance between the two particles. And we had said that basically this force can be represented in terms of a formula, whereby we say that there's a constant of which is a Coulomb's constant, and then the product of the two charges and the square of the distance between them. And this one constituted of a unit vector which we had given in terms of R. And therefore this gave us a relationship being given by these two specific particles in terms of charges, the forces they are experiencing, and the distance of the separation between them. Now, in our discussion today, we are going to look at another version of application of the Coulomb's law, but this is going to be considering a system of charges which are more than two in number. Now, therefore, this is going to be giving us a clue on how we can treat a system of charges which are particularly more than two in number. And therefore, we're going to see how this relationship is going to develop from the Coulomb's law to these two specific or this other representation of a system of charges which are more than two in number. Now, I'm going to consider the case for this particular illustration which I've given on my left side of the board. And this is going to form my charge 1 given as Q1. And then I will have this one given as Q2 and Q3 respectively. Now there's going to be a specific distance of separation between the two, and as we can see from this one, they have been given in terms of their specific charges, and therefore we are going to expect this one to be experiencing an attractive forces between the two, whereas these ones have been given a radiating or rather force which is going to be a repulsive force experienced by this Q3 due to the presence of Q1 and the Q1 due to the presence of Q3 given as such. So the distance of separation which is R between the two, so this as well are going to be experiencing attractive forces. So the distance of separation for this one is 2.48 times 10 negative 6 meters. And then this other one, the distance of separation between Q1 and the Q3 is 2.0 times 10 negative 6 meters. So this 48. And then we are going to have this other distance of separation between these two specific charges given in terms of 1.6 times 10 negative 4 meters respectively. Now, having been given the value for R for the for the two pairs of charges, or the set or different sets of these pair of charges representing various forces and the distance of separation. Therefore, we are going to be using some strategy in order to find the forces of attraction being experienced by each of these particular particles. Now, this is going to be a system of more than two charges, as I have said, and the N1 charge is going to be the force being experienced by N of these, or rather the force being experienced by N of this set of three charges is going to be the sum or the vector sum of the forces exerted by the other charges present. And therefore we can give this one in terms of a representation so that we can find a general way of representing the various forces being experienced by either charge 1, charge 2, or charge 3 in that specific order. Perhaps we can start by a representation of the force being experienced by the charge Q3. And as we said, the force being experienced by the charge of Q3 is going to be given as a result or a vector sum of the forces experienced due to the charge of Q1 and Q2. And this can be represented in terms of the resultant force for Q3 is equivalent to the force of 1 on 3, and of course the force over 2 on 3 given as a vector sum of those two specific forces. Now from the Coulomb's law, we can individually represent the various forces which we have listed above, considering the charges for 1 and 3 and 2 and 3 in that particular order. So therefore we're going to have this force given in terms of F3 is equivalent to F1 on 3 can be given in terms of the product of charge 1, charge 3, all over the distance of separation between charge 1 and charge 3. But remember, from the general case for the Coulomb's law, we are given this specific constant, the Coulomb's constant, given in terms of 1 over 4 pi epsilon naught. So that's going to constitute part of our calculation. So therefore, we're going to have the distance of separation between 1 and 3 being given using this specific notation. And that's going to be going in that specific direction using that particular vector which I've given above, which is basically a unity vector in that specific direction. And then we're going to have the sum of that one with Q2 and Q3. And this is going also to be over this specific Coulomb's constant and R3 over 2, R3, 2. And this is the distance of separation between 3 and 2 being given as such in that specific direction, as we have said. So we can just do a substitution for this specific, but as well as we can see from this one, we can just have this one as a compressed form by using this specific constant as a factor. And then we're going to have this one multiplied with Q1, Q3 all over R1, 3. And the two force, the two specific distances of separation, which we had said is basically the square of the distance of separation, and therefore they are going to appear as such. So we're going to have this one as R1 on 3 squared plus Q2, Q3 all over R2 on 3, and this is going to be a square. And then we're going to have for the two respective representations this specific unit vector being given as such. And that one is going to give us the force, of course, which is going to be experienced by Q3 due to the presence of Q1 and Q2. So if we do that specific calculation, then therefore we're going to find a particular value that is going to assist us in trying to find the other values using those specific force. Now suppose we find of course, the forces of attraction between. Now, because of the limitation of space, perhaps I can just do one example and just give a value and do that specific sum. In case you find a difference, kindly notify in the comment section so that we can be able to check on it. So this is going to be force 2 on 3. And as we had mentioned, of course, this is going to be given in terms of this specific sum. So we're going to have this one given as such. So in this case, if we are going to be calculating that specific type of force, and then therefore we're going to be using that specific formula. So in this case, I found a value of 8.9875 times 10 negative 21 newtons. So kindly do an evaluation of this one by doing a direct substitution using the procedure that we have done above. In case you come across a different value, kindly notify us in the comment section so that we can be able to do a follow-up and find what exactly that specific value is. But assume that we have seen how the principle of superposition can be applied in case we have a system of charges which are more than 2, whereby we say that we are going to apply this principle of superposition whereby the n of one charge, the force that is going to act on n of one of these specific charges is going to be a vector sum of the forces being applied by the other just as I've just illustrated. So kindly check our description boxes for various links of other videos, and also subscribe and engage us in the comment section, and also ring that notification bell to be getting updates on our various uploads and different topics under the concept of electricity and magnetism. So that is it for now, guys. By God bless you. Catch us in our next video.